So, hello everyone. Hope you all are enjoying. Today, I, on behalf of Developer Student Club in IT Patna and Hacksless Club, extends a warm welcome to all of you who are present here and have joined us all the way. So, we are today very fortunate that today we are having among us a very meticulous and passionate engineer, Shivay Lamba sir, and he is having over 300 plus hours of industrial experience, and sir is deeply interested in various cloud technologies like Docker, Kubernetes, and all. Apart from it, sir is highly experienced in the field of full stack web development using Node.js, React.js, and Amazon Web Service. And he's also working on machine learning using Keras, TensorFlow, and a lot. So today we are very pleased and we are very glad, sir, that you are here to teach us something which of which we are very unaware. So today we are going to learn a lot from you, and we extend a very warm welcome to you, sir. So now it's over to you, sir. Please.
Yep. Thank you, Rasvi, and for such a warm welcome. And I'm really excited to be presenting today in front of everyone an introduction to cloud computing and microservices architecture, where I'll be talking about what exactly is cloud computing and what's the kind of relevancy that it holds, particularly today in this kind of a digital era. And we'll be talking about what exactly is microservices architecture in this specific presentation. So if you mind, if we can share my screen, great. All right. First of all, just to sort of give a very brief introduction about myself, I'm Shivay, and Rasvi did a really great job also explaining about that. So some of my previous experiences, specifically with cloud computing, have been in the form of being a Google Summer of Code mentor with the CNCF Foundation, that is the Cloud Native Computing Foundation, where I mentored students in the field of service meshes. But apart from that, I've also been deeply involved with a lot of different cloud technologies, specifically working with AWS in a lot of different production environments during my previous startup internships and other internships as well. So I'm really excited to be presenting today in front of all of you the concept of cloud computing, because cloud today has become the de facto standard when it comes to running and operating various kind of systems, softwares. We know that with the advent of our coronavirus pandemic that happened across last year, most of the businesses were forced to run virtually, and people were forced to work from their homes. And what happened was that a lot of these businesses, although they were shifting from legacy systems that used to be running on very large hardware onto the cloud, but that sort of just accelerated and it exploded in the last year after all the businesses were forced to make an online presence. So the rise of cloud computing has been there ever since the 1990s, 2000s. But what we're seeing is that it has overtaken any form of other kind of competition in the last few years. And now even small businesses or large businesses, small companies, large organizations are all now having an online presence on the cloud. And so that sort of makes it really important that we understand what exactly is cloud. And today, like earlier, for example, let's say if a backend developer job requirement said that, hey, you should be able to write backend code, tests, write let's say documentation. Today, having knowledge about technologies like cloud, like for example AWS, Docker, Kubernetes, it has become quite essential and is almost sort of has become a necessity. So it's really important that we are able to understand what are the main concepts of cloud computing, and we are able to apply them to basically in our day-to-day life as well. And for example, those people who are interested in any kind of a development, they should know at least some part of cloud computing in general, because since I've already said that everything today is on the cloud. So without wasting any other time, I would like to first talk about a bit of sort of revisit what exactly is the different types of computing. So initially, we all started, and this is something that if you have sort of gone through let's say if you have gone through your cloud computing classes in college, or you have heard about cloud computing earlier. So earlier, when like whenever, for example, and again, just to sort of define what exactly is cloud computing all about, I would first like to talk sort of step back and talk about what were the different types of computation that we used to have. So first of all, we had like desktop computing. That is whatever you're working on locally on your hardware, which uses things like your power supply, your motherboard, your laptop RAM, and your laptop processor, right? Then we have something called the client server computing. So what exactly happens in a client server computing is that like whenever you have like a computer network that is connected to, let's say, multiple computers connected to each other via server. So you usually will find this kind of a combination locally in a small startup, sorry, in a small company or in a small workplace where we have a common server. For example, it's also quite common in banks, right, in retail shops. And so this kind of a system is when you have a limited amount of space and there are a few computers that are connected to the same network, and they're operating on the same, let's say they're operating the same software or the same hardware. And then we have something known as the cluster computing, when we have, let's say, more than two or three cloud we have basically more than two or three client server connecting with each other and sharing their resources. So it's not just one client server, but there can be multiple such client server. So for example, let's say if we are talking about just a single retail shop, if in case it was like a sort of a mega mart or like a mega mall, and they want to utilize the same kind of a network, but in order to achieve more sort of more growth and achieve more complexity in terms of the number of nodes that we have, like the number of computer nodes that are there. So we can use the concept of cluster computing, where we are combining more than two client server computations and sort of operating them at the same time. And then computing is when we are basically having different types of client servers, but they're sort of located in separate geographical locations. So it's not just limited to one environment or just one company. You'll have, let's say, multiple services being run in different parts of the world, and all of them are like sharing their common resources on like, let's say, from the server side. And for example, it could be, let's say, different branches of a bank in a single let's say in a single city or in a single country, where the different branches are operating on the same software, that is the banking software, but they are all connected via the internet and sharing the common resources, that is, for example, let's say the common database. And finally, we come on to to the advent of cloud computing, which can be treated sort of as the combination of like the grid computing, that is having a worldwide presence, but also combining the features of clustered computing. So we just spoke about cluster computing, that giving the ability for multiple servers, multiple services to connect with each other and provide us the kind of competition that is necessary for running businesses, right? So essentially, what cloud computing is all about is that it is like it is like it's a means to basically store and access data and programs that are not requiring a separate server to run, but they can be operated via the internet, via the web, and you're able to connect to the cloud via an HTTP connection. That is like sort of a secure connection that takes place between the cloud and your PC, or like, for example, let's say whatever computation resource that you are using, right? So coming to the next slide, basically, we have different types of deployments for clouds. So basically, these depend on, let's say, your usage or what is the party that is using it, right? So the first one, that is the private cloud. The private cloud is usually owned by a specific entity or a small scale organization that uses the cloud for its own services, for its own employees, for running its own applications and processes, right? And usually the private cloud is more secure, because again, it's like a dedicated machine that is only being provided to that specific company. And now coming on to basically some of the disadvantages would be that it is having a higher cost, because since like you're having a limited amount of resources, and since it's sort of very exclusively limited to your company, the charges that will be there might be a lot more, because we are having like a trade-off for security and having a sort of a dedicated server running as well. And now coming on to the public cloud. So basically, a public cloud would be the one that is generally used by public. So all the operations and all, let's say, the resources that are provided by the public cloud provider are generally open to the public as well. And a few of the examples for those would be AWS. It would be Dropbox. These are the services that help provide you ability to actually use their servers, and you use it for your own let's say application. For example, using Dropbox to store important files that you might be having from your workspace. But usually these are shared. So what does that, like, the keyword share mean is that the resources that are being provided to these cloud services, and again, it's really important to know that we say that we are able to connect to a cloud service and use that service, but in its most base form, these are servers and these are computers that are residing in huge data centers, and these are the ones that are allocating you the bandwidth, the computation power to actually connect to the cloud, connect to such kind of applications that are running into the cloud and then utilize them. So they are also being run on some dedicated softwares, dedicated hardwares that have been provided by these cloud computing companies. So when it comes to like a public cloud, the again, the amount of resources that a cloud company can have, those are limited. So usually what happens is that there's a sharing of the resources or sharing of the different types of compute power that we are using. So since it's shared, again, like it is definitely having much less secure security in terms of being exclusive. So it's more open and it's more prone to attacks, and usually it will cost you less, as it usually follows a model of pay per use. So what does that mean is that you pay for as much as you use the platform. And finally, we have the hybrid cloud that basically combines the features from both the private and from a public cloud. Basically, it will have a combination of private cloud, a combination of public cloud, and you can use basically whatever you are comfortable with and whatever your specific use case is, right? So now coming to what are the different types of models that are being used for cloud. And so what does this mean is that how are we utilizing the different types of cloud services? So the first one is infrastructure as a service, or IaaS. So basically, infrastructure as a service means that what we're doing is that we're providing like a fundamental service which provides the computing resources in a virtualized environment. So what does this kind of a virtualized environment mean? That basically the server that is usually running, that is giving you the computational power, is basically running in in these sort of the service providers data centers. As I've already said, that these cloud platforms or these companies are having dedicated hardware that they store in these huge data centers. And in case of infrastructure as a service, basically you will be directly given access to these resources, and you can use them for whatever you want. But basically, the entire control will be managed by the customer who's using this kind of a virtualized environment, but they're actually utilizing this kind of a server to work on any kind of an application that they would want. But it will only give you sort of a bare bones structure in terms of the overall resources, and it's totally up to you how you want to utilize them, how do you want to operate on them. And it will give you certain things like sort of the server space, network connections. All of those will come in handy when you want to use the cloud for as an infrastructure as a service. Now coming to the next part, that is the platform as a service. So basically, in this, what happens is that you'll not be given a direct access to the infrastructure, but you would be given certain services. For example, let's say being able to give servers and being able to get sort of service providers that use basically the cloud. And for example, what does this mean is that you're not only getting the server itself, but you're also being given the operating system, a few softwares that you can use, and like also being given some mostly used applications that are actually pre-built and running on the server. So in terms of customizability, it will be lesser as compared to infrastructure as a service. But with platform as a service, you're being given a few tools that will be quite necessary for any kind of an operation to actually go ahead. And so that sort of saves you time in case if you're opting for cloud computing for platform as a service. And again, like all the different services, all the different such kind of applications will be hosted on the cloud and will be accessed virtually using the virtual connections that we make on the cloud. And finally, we have something known as the software as a service. So basically what happens is that in this scenario, you will be given access to different kind of softwares that are actually again running on the platform owners data centers, and you're given direct access to these services, to these already installed softwares, and you don't need to necessarily install them locally on your PC. A few examples could be the Office 360 applications that we can access through the internet, Adobe suite of applications that run exclusively on the cloud. So all of these different services are pre-built on some kind of a hardware that is again part of the cloud computing companies or organizations computing resources, but they are giving you an access to directly utilize these softwares. And you won't be given access to the hardware itself, but you can directly just log in and start using these services on the go without necessarily having to install these services on your PC. So that helps basically tackle the problem of not being able to, or sort of the hassle to actually install large applications on your system if you are sort of limited in terms of these storage. So basically what we are seeing over here is that so far we have discussed about what exactly is cloud computing. We have discussed about what are the different types, like what exactly were the different services that are being provided by cloud computing. So essentially, since I've already said that today most of the services or most of the softwares or most of the organizations are making an online presence, right? So from going ahead and utilizing large servers that were running and being used to actually create the application, today all of them are sort of becoming part of the virtualized environment, and most of the companies now are shifting to an online presence, to a cloud based presence. And that is why it sort of becomes important that everyone is aware of those technologies that are involved in cloud computation. And that is why the next topic that we are sort of coming to is talking about the microservices architecture, and what exactly are microservices, what exactly is Docker, Kubernetes, and how are they useful, or how are they relevant today in this kind of an environment that we are in specifically in the cloud computing world. So apart from that, I just wanted to also sort of give an example of some of the popular cloud computing services. So we have AWS, that is Amazon Web Services. We have GCP, that is the Google Cloud Platform. We have Microsoft Azure. We have DigitalOcean, and there are a lot of more other such kind of cloud computing services that provide you services ranging from creating very simple web application deployment, for example, like Heroku, that helps you deploy your front end or even like a back end service. But they can go all the way to as complex as creating complete pipelines for machine learning based projects running on the cloud. So today we have sort of come up, like from we have come a very long way ahead in terms of the overall computation that goes into cloud computing. And today is a really good time to sort of dive into the cloud, because it's one of the biggest growing fields even today as we are speaking. So sort of from there I'll be sort of wanting to speak about the monolithic architecture. So what exactly is the monolithic architecture, right? So see, basically, if I have to sort of break this down into a word, so monolith means composed all in one piece. So what does that mean is that let's say you're having some kind of a hardware, or let's say a software, when it's like combined into a single entity, that is where sort of this concept of the monolithic application comes into the picture. So usually, like how we describe the monolithic architecture is that it is usually like a single tiered software where you don't have like differentiation in terms of different layers, and it's like it comes as like a single platform. So you can sort of think of that as a single platform, and it's not like having different layers, or it's not having different services, but it's all the different kind of functions that the application perform sort of wrap around itself as a single application, as a single service, as a single program. And that is why we sort of call it a monolithical application, when everything has been tightly packed together, right? So again, like what it says, that in layman terms you can see that there's a very big container that contains all your different software services components, and they are tightly packed. And if you can look at the architectural diagram, so you can see that in case of a monolithical architecture, you'd be having this entire sort of this application and all its services being wrapped around as one single entity, and all the kind of communication that goes on will be within the actual environment itself, right? So that should sort of make you understand. And what we know is that usually a lot of these systems, they always start off as with this kind of a monolithical architecture. And again, like I'll be talking about what exactly does it really convey, and how how it is being used, or how you can utilize the monolithical architecture for your own project as well. So I mean, like first I would like to sort of also give you an example of a monolithical architecture, as like to better make you understand. So we know that like e-commerce platforms today are really popular, right? So basically, for example, like you can take an example of this kind of an example, where for example, let's say we are having the store, and the store has, or this kind of an e-commerce platform has a lot of different services. For example, we have the catalog services, order services, payment services. So basically, catalog would correspond to the product, order service would be corresponding to the order that actually takes place, and payment service would be to the actual payment that you make. So you have accessibility via your mobile device, via your desktop browsers, and you have all of this entire sort of e-commerce platform as one single entity, with all of these different services interacting with each other. Whenever you select a product, add it to the cart, and you press the order button, there's an array of all the different items that you're buying, and those go into the ordering system. And once your order has been confirmed, you connect that to a payment gateway, and you sort of make the payment. And finally, all of this kind of a data is being stored in a single database with different tables, a table for orders, a table for products, a table for payment history, right? So everything that is happening is enclosed within one environment, one entity, and that is the e-commerce platform, right? So this should sort of give you a basic understanding of what exactly is the monolithical architecture. And that is why sort of making understand that how it is actually function. That, for example, let's say even if you're having like a single server side application, you might be having like a cloud service, like let's say that stores the database, and there could be like client side UI that you're interacting with, but everything is happening within this space, right? So they, again, like there are benefits, and there are also a lot of drawbacks when it comes to utilizing the monolithical architecture. And I would like to sort of give more sort of more insight on like what are the really good benefits of actually creating this kind of a monolithical application. Again, the biggest one is that it is super simple to build, right? So super simple to develop as well. So for example, because the thing is that you're having a single application, all your different functions that you're writing will be part of that same application. For example, let's say you're creating an e-commerce platform for that matter, and you're using Node.js. So you're creating all your different routes, for the payment services, for the payment gateway, for the ordering. You're creating your middleware, your routes, your APIs as being part of the single application. All your different front end routes. Let's say you're using React, so you're having different kind of JS files. All of them are being part of a single application, and that sort of makes it much more easier to sort of conceptualize and build, right? And then again, it is simple to also test, because we can just create a simple testing framework for the entire application without having to worry about it having different components and all of them being stored differently. So we can have one framework to actually or like basically create a common sort of a testing framework that can be used to create the tests and sort of run those tests over the application. And then again, it is usually also very simple to deploy, because when we're deploying such kind of an application, we can package it as a single entity and then just host it on, let's say, a server, or host it on some kind of a hosting platform, right? And then it is also simple to scale horizontally, because we can have, let's say, multiple copies of the same software running with the help of a load balancer. So what exactly is a load balancer is that depending on the traffic that is coming to an application or to a service that we are running, usually what happens is that in case you're not having, let's say, a load balancer, and you're just running a simple server, and let's say there's a huge load like, let's say there's a huge traffic inflow that comes to your website or to your application, then there's a possibility, in case you're not doing something about being able to manage such kind of large numbers, your entire application can actually sort of stop because of the huge amount of load. So basically, to look at those kind of situations where we might not have to face things like huge amount of traffic coming in and closing the server, we have the concept of load balancer that basically automatically scales up your resources that you have in your cloud platform or in your service, and it is automatically able to allocate more amount of resources in case there is a huge upstream of traffic coming into your platform. And when, let's say, there's a very less amount of traffic coming in, it is automatically able to scale down your resources. So basically, it is able to manage the traffic load that comes into your system. And there are two benefits of using this. Since it creates like a dynamic system, you don't have to worry too much about the amount of traffic coming in, because it will be able to intelligently increase or decrease the number of resources based on the condition, or based on the current situation that is going on. And again, one of the other things to keep in mind is that with respect to the load balancers, it also helps deeply or greatly in terms of the overall cost that you might have to put up, because in case, let's say, you estimate that you will be receiving 10,000 users on your e-commerce platform on a daily basis, but really it's not even half of that. But fearing that your server might die down in case you find an upsurge in the number of customers or traffic. So by using a load balancer, since it automatically reduces or increases the amount of resources that you need, and it will and again, like, it's situational based, it helps you sort of also avoid hidden costs, or cost of always running maximum amount of resources or maximum bandwidth of resources. And it is also great for the companies that are running these cloud platforms, because then in case you are not facing an upsurge, they can actually allocate those resources that might have been utilized and being wasted by you to some other for other kind of use as well, to sort of also make the cloud platform benefit and utilize their resources in a more intelligent manner. So load balancers are really popular and a really important tool when it comes to running your applications on the cloud and running them smartly. So it's really simple to sort of scale these kind of monolithical sort of these monolithical like these applications horizontally using with the or with the help of load balancers. So these are some of the benefits, but like, we also would want to look at some of the drawbacks that sort of come up when we are using these monolithical architecture and we're using these monolithical tools, right? So the first one is, again, the maintenance. So again, the biggest problem is, for example, let's say your application is really huge. It is being used by multiple companies, by people across different geographies. It can actually become quite hard, to sort of understand. And for example, let's say if there is some kind of a bug that comes into the system, then it would be really difficult for you to actually debug where does the problem exactly lie. And what happens is that in case and like this is a direct consequence, that in case the size of the application is really huge, that can actually slow down the time, for example, whenever you're restarting your server, right, it becomes really time consuming to again wake up the application and you start using it again. And one of the other problem is that you have to redeploy your entire application with any kind of an update that you make. It's not that you're only updating, let's say, a part of the application, and only that needs to be reset. You will have to reset the entire application as it is. And then again, like, monolithic applications can also be challenging to actually scale up, in case like, again, there might be certain parts of your system that are not being used that much, and there might be parts of the application that might be used a lot, and there's a greater need to actually scale up certain parts of the application as compared to others. For example, let's say scaling up your payment system in case of some kind of a deal that is going on your e-commerce platform. And then probably the biggest one that is there is the reliability factor. So let's say you're having a bug in one of the most important processes. That would mean that that can actually result in actually making your entire application go down at the same time, and that can impact your entire application. In case there is a bug in the registration, or let's say in any kind of other service that also sort of is dependent on other services, that can sort of bring down your entire application to an entire halt. So reliability is one of the biggest drawbacks when it comes to working with monolithic architecture and monolithic applications, right? And the monolithic applications are also equally difficult to actually adapt themselves to the latest trends, or let's say the latest technologies, because since the entire system is so tightly packed, it's difficult to replace some kind of a code base and change it completely, because a lot of the other services and functions are actually dependent on each other. So it becomes difficult to, and again, like, it becomes a very huge time consuming effort to actually introduce some kind of a new technology. And so if like, to basically address all of this, we introduce the concept of the microservices, right? So just to first understand what exactly is microservice, basically it is an approach that does not involve the use of an entire application, but really what it does is that it basically converts a large application, or a full application, into a suite of different services. And these services are completely modular. That means you can interchange them, you can add more number of services as you want. So it's sort of becomes sort of a plug and play kind of an operation that you can sort of correlate it to. For example, we have Lego pieces that build together to form different shapes. Similarly, you can think of microservices as Lego pieces that can be combined to one application, and run that application with the help and with the communication between these different kind of services. So instead of like sharing like a very large or like a single database, each of these services that run independently have their own database. So there's no dependency on a single application. And like, just to sort of quote, the microservices are an architectural paradigm that sort of break down the entire application into smaller applications, or we can call them micro applications, which are packaged and deployed independently. So what does that mean is that all of these independent entities, or these micro applications that are running individually, are being packaged and they are deployed separately, and independently from the other services. So the question arises that hey, I mean, like, when we had one common application, all the different functions, all the different services were being run as part of a single application. So how does like the communication actually go, and how does it actually function, right? So that is what I'm going to be addressing in the next part, that is basically understanding the microservices architecture, right? So like this is a really good example of what exactly is like the architecture all about. So as you can see from the diagram, what we have at the top are the clients, right? These are the clients. It can be again people accessing some kind of an application via their smartphone, via computer, via directly a cloud. And then what we have are some of the management capabilities. For example, let's say there might be certain um, applications that the users might be using. So for example, let's say geography. It could be some kind of settings that they are utilizing, and any kind of like an application. And what's happening is that these microservices, since I've spoken that each of them are individual entities on their own, right? So internally, how they're functioning is that each of these different tools will be having its own server, will be having its own service being run in the background, and they are not interconnected with each other, right? So the operation of one service will not impact the other. In case one of the service goes down, it will not impact the functioning of the other, because all of them are serving individually. And the most important question then that sort of comes up is, how do these individual services communicate with each other, right? For example, let's say I have an example of an e-commerce website where like again I showed a similar example in one of the earlier slides when we were talking about the monolithic architecture. We have an online shopping service, an e-commerce platform, and earlier we showed that it had all the different services of the catalog, the order services, the payment services as under one architecture. Now, for example, let's say that it actually does not follow the monolithic architecture, but it instead follows the microservices architecture. So we'll be having different services, different functions that are running individually of each other for each of the main functions that the e-commerce platform performs. For that matter, it would be the let's say the catalog service being a separate microservice, the order service being a separate microservice. And how are they communicating with each other is basically through HTTP requests, through API calls that sort of go ahead and like help communicate from one service to another. And that is where like I was talking about the microservices architecture, that you have these different kind of services, all of them are running individually of each other and performing different functions. But internally, if for example, let's say you want to forward the data of your order to your payment, for example the total amount that you have to pay. So basically by using these HTTP requests and message bus that help transmit the data from one microservice to the another, right? So these come under the operational capabilities of how the different microservices are interacting with each other in terms of transferring of the data that needs to be put in, right, to the application. So this is like how the services or these microservices work internally. So that should give you sort of an idea. And again, like coming on to like the most important aspect is like what are like really the benefits of using the microservices, right? So some of the like the advantages that I've already given to you are that the microservices enable in continuous delivery and deployment of large complex applications. So what does that mean? First, I would like to sort of speak about what exactly is continuous delivery and continuous deployment, or as people call it, CI/CD. And today it is one of the most important aspects of software development, of software computing, specifically when like most of the applications have been deployed to the cloud. And so what does the continuous integration mean is that whenever you're creating any kind of an application, let's say you are adding more and more features to it, right? So instead of actually running the application or starting the application again and again, you can continuously add more and more features to it, and those can be integrated to your current platform or to your current application. And continuous delivery is that you're consistently deploying your application like without any kind of a hassle, and it will actually do it for you automatically without having to, like, let's say, write the deployment script to actually deploy a particular hardware or a software. And since microservices enable you to break down your entire application into individual units, it becomes super simple to deploy very complex applications that might be having hundreds of services. But since these individual services are running alone, it's much more easier to sort of manage sort of deploying such large applications. And then we have better testability, that since each of these different services are smaller, we can test each of them individually, and they will be much faster to test as compared to testing your entire application. And then since these services can also be deployed independently, it just helps you basically manage the deployment far more easier and in a much more quicker time as compared to deploying a monolithic architectural application, right? And also it enables the to sort of organize the development in terms of, let's say, if you have, like, let's say, an engineering team and you're creating a combined project, so each team can sort of look at individual services or a collection of different services, and they can start working on that, and sort of that helps you manage and lead the project in a in a better way. And again, like, if you're working on a single service, it's again much more easier for developers who are just getting started, right, to actually use them. And one of the most important one is that the application will start a lot more faster, because now your application is not dependent on some of the redundant features, some of the redundant data that we might that might not be used, and it will only call in those services that are responsible for deployment or that are responsible for the startup, right? So that is why the applications do increase, like, they definitely have an improvement in terms of their start times and overall snappiness when it comes to running the application. But again, like, not all is roses in terms of, like, studying about the monolithic architect about the microservices architecture, because again, like, there are certain drawbacks. So one, probably the most important one that I would like to discuss is the complexity of creating such kind of a distributed system. So sort of this sort of draws us back to our first ever understanding of what exactly are microservices, right? What exactly and why are they introduced? So we have something known as loose coupling in microservices, because instead of sharing a single data resource in a monolithic application, each microservice will have its own data. It will have its own database, right? So basically, having a database that is exclusive to each service that is essential uh, is basically the loosely coupling of the data. So what does that mean is that each component that we have will be having loosely coupled service that is running as per the requirement. Whenever it's needed, it will start running. And because all these different services are loosely coupled, there is no interrelation between them. It sort of makes it it can be complex for people who have been building these monolithic architectures beforehand, to actually understand how to create a distributed system, because in its core, the microservices architecture is a distributed system where you're having different services running at different time zones, and they are being hosted differently. So it sort of becomes a part of the distributed system, right? So definitely, when it comes to starting out with microservices, it can be slightly difficult to understand the how does the distributed system actually work. And then usually most of the developer tools that we utilize, they don't really provide support for developing these distributed applications. And again, like, when we are having the distributed applications, there is no one test, right? You'll have to write individual tests for each service. And while that makes the overall like, testing easier, but then because we're having so many different services, and again, with more complexity, you'll be having to write a separate entity, or you'll have to write like a separate test a case for each service, because each of them are unique, right? And again, the developers must have the inter-service communication mechanism ready. That is, like being able to create those HTTPS protocols that help enable transfer the information one um, from one part to another, right? From one service to another. So the developers must be able to understand how does that kind of communication goes ahead, right? And again, when it comes to the deployment, we have said that like it's much more easier to deploy, but in terms of the complexity in production, basically we have to look at how many different types of services are there, how many different types of, like, what exactly is the complexity in terms of the deployment. And again, let's say we are having like again, and in certain cases the memory that we consume, there can be like higher amount of memory that might be used. So that again, like that sort of sums up the drawbacks of microservices. But again, given today's legacy systems and how they are being actually broken down into microservices architecture is definitely like the future as compared to a monolith architecture. And most of the businesses are now today like running towards this kind of environment, where we are now embracing more of this kind of a modular system in terms of the cloud as well, in terms of the different services that we are using. And such kind of a modular architecture that is specifically being used in microservices architecture will be used. So that should sort of give you an idea about the microservices. Now coming a bit to containers, right? I spoke about things like the microservices, and now it's very important to understand what exactly are containers, right? So we have spoken about these kind of services that, right, we have. We spoke about how these microservices are interacting with each other, right? So it sort of just becomes important to also understand what exactly is uh, the containers. So basically cloud containers allow to, like, basically the developers to package or to sort of create their entire application and run that as a container. And basically a container is nothing but it's like a configuration that sort of enables you to basically, again, like run the application in the same way. And what does that mean is that it does not it really does not consider which particular environment or which particular operating system that you might be on. You're able to basically have a single configuration for your application, and it, like, that same configuration can be run on any kind of a platform. And this makes the applications a lot more portable, without like the need to actually develop a new code or make your application accessible uniquely to each platform, right? So again, it makes the overall portability of your entire application really simple. And basically what does that mean is that these containers can be used anywhere and just deployed, and your application will be good to go, right? Again, like how do we actually create these containers? So we have different services like Docker that help in the containerization of an application. Usually it involves a number of different steps that you write to basically create like a package, your entire package, and you sort of write commands that help the users to understand how to like deploy and how to install your application if they actually also want to run your application. So it basically is essentially a configuration file that defines how to actually utilize, how to download, how to start running your application. And it could be, the configuration could have like the scripts to help people install the dependencies that might be in your cloud, and then start utilizing them, right? So that sort of is what exactly is the main application of containers, right? And then coming on to like basically some of the best practices that one must actually follow when they are kind of like making like, or when, like, for example, if you want to build your own microservice architecture. So what are the best practices, right? So we just spoke about what exactly is a microservice. We spoke about what are containers, right? We spoke about things like uh, how the microservices are better as compared to the monolithic architecture. So the first one is that, as I've already said, that keep a separate data for, or like a database for each of your microservice. Because what happens is that there's no dependency, and there is no need to wait for one of the microservices to give the result. And like, what happens is that it all makes the entire flow of your application a bit easier to understand in terms of the number of API calls that you have to make. And since each one of these data stores have their own like database, like each of these microservices have their own database, it just makes it a lot more simpler to like just create like a separate data store or like a separate database for each microservice. And then keep your code at a similar level of maturity. So what does that mean is that the code quality, using the latest best practices when it comes to the programming, just keep your code in across various microservices in the same kind of maturity in terms of its current versions, because in case there is an incompatibility in terms of the versions, then that might lead to an error. So again, for example, the next would be create like separate builds for each microservice. So what does that mean is that, for example, let's say your biggest build is the for example, let's say you're creating an e-commerce platform. So the biggest bid, or like the biggest build in that scenario, would be the actual site itself. And right, so basically creating like a separate build based on when it was updated, how was it updated. You can create like separate build and use your latest build, and it will enable you to like, even if you have different version of build, it will enable you to actually run that. And then always deploy in containers rather than deploying the application, or let's say even a service. What you can do is that you can write a configuration file for the deployment, and you can start using that, and that will also provide like sort of a way in which you can actually deploy your application, start running it anywhere easily with the help of that configuration file, the help of a Docker file that you can create to basically configure your entire application, right? So that should sort of give you an idea about the deployment in the containers, right? Deployment of how we can create like a configuration file and share that. And finally, treat the servers as stateless. So what this particular line means is that the servers that you're running, those are not having any particular state, or those do not belong to like a particular state. So they are stateless, they are serverless. And that is like the most like two most important points that sort of come up when it comes to these kind of platforms. So that sort of like brings me to an end to topic of the microservices. And again, I would also like sort of love to talk a bit more about the concepts of Docker, because again, like, it is quite essential when we are like for example, when we are speaking about being containerizing our applications. And again, the most important part is that like containers today, since everything is virtual, so we don't have the ability for the offices to be actually running, um, like offices are not running locally, right? All the people who are working from their home. And let's say if I wanted to test out a build of an application on my PC, it's not possible to do so directly, because again, I'm not at an office space where we can share our resources. So basically, Docker and other kind of services were introduced that help in the containerization of the application. So Docker is like a software platform that is used to build the applications based on containers, right? That we already said are very lightweight execution environments that help like make the shared use of the operating systems that we have, right? So Docker, again, to just sort of give you a background, is an open source like project that was made, and it was like launched. It has been quite some time since it was launched, right? So basically, as we know that containers, they help you isolate your environment from one another. So that, what does that mean is that uh, we are able to create these containers, right? And Docker is something that helps you create these containers, right? So a Docker project will basically help you create containers and container based apps as well. And so basically the main infrastructure of how Docker actually works is that each Docker file, for example, let's say whenever you want to start off with a Docker container, it will always have a Docker file. And the Docker file is basically a simple text file that has a very easy to understand syntax that includes the instruction to basically create a Docker image. And I'll be speaking about the Docker image in a bit, but basically a Docker file will specify like any kind of an operating system that will be based on the container, along with, let's say, what kind of languages are being used in the Docker in that particular application that you're making a container of, what are the different environment variables, network ports that will be utilized. And again, like, all of this will be necessary when you build and you use your Docker image or that containerized application that you run, because you need a metadata like the environment variables, the languages that are supported, so that you can install those necessary language and their latest updates in terms of uh, um, like updates in terms of how they're functioning, right? So basically, like, the Docker file is essentially a configuration file that I've already spoken about, that contains the instructions to build a Docker image. And so again, like, the next question would be, what exactly is a Docker image, right? So basically, once, let's say, you have created your Docker file, we have a lot of different kinds of commands that are written in Docker. So Docker, again, like, you'll use Docker mostly in the command line, and then we have something called the Docker build command that basically creates an image, right, based on the Docker file. So whereas, like, the Docker file itself is the configuration or the set of instructions, a Docker image is like a file, again, like, it's portable, that sort of specifies the information for which tells that how the different specifications, or how the different kind of components that might be there in the overall application will run, and how they will interact with each other, right? So basically, a Docker image, what it will do is that, basically, for example, let's say a Docker file will be helping you create these Docker images that are, like, basically containing the real information on how to actually understand and how to build these applications. So then, for example, we have the Docker run command that will actually launch a container, right? So essentially, you can think of the container as an instance of the image, of the Docker image, because containers are, like, designed to be run anywhere. They can be stopped, run at any point of time, anywhere. So it's essentially, the containers are these images only from Docker. And now, whenever you create any kind of a Docker image, right, you create any kind of a Docker container, if you want it to be global, if you want it to be shareable across different platforms, across the internet, then we have something known as the Docker Hub. That is basically an open source platform where you can share and manage your containers and create, like, official Docker images, so that you can actually share it with everyone. It is being used by companies that provide you these containerized applications of open source projects, of paid projects that you can be a part of, and all of these are hosted on this single platform called the Docker Hub, right? And basically, a Docker engine is something that, like, again, it sort of is the core of Docker, where it helps create and actually run the containers, because we said that using the Docker build, you're able to build an image, right? But how does it actually build internally? It is using the Docker engine, but as a means to basically run these containers. And finally, I would like to also like speak briefly about the concept of Kubernetes, because like Kubernetes is again a really important topic when it comes to like working on the computation. It's basically helps so what Docker did was that it helped you in actually building these containers. But let's say you're having a very large application, you're having a bunch of different Docker images that are corresponding to a same project. again, each of them, let's say, serving as individual services, right? Being part of a very large um, application. So Kubernetes is again like an open source system. We call it like an orchestration system, or like a container orchestration system, that helps in the deployment, scalability, and management of containerized applications. Because usually a lot of times what will happen is that you might be having a lot of different containers as being part of the same application. So being able to actually manage them, helping manage the with the deployment, because it can become quite difficult to like sort of deploy each container, as it is like it can be very confusing. So it sort of, Kubernetes as a tool helps you just manage all of your different containers that you're using, um, and it helps in deployment and management of when to use which particular like sorry which container to be used when at what time. It sort of helps you sort of manage that. And again, like Kubernetes is again one of the most popular services that are being utilized right now. So that sort of, like brings us to the end of, at least from my presentation. I'll be really happy to take up certain questions. And again, like this sort of recap of what we covered today was basically starting off with what exactly is cloud computing, what exactly is the microservices, and how they are better than the monolithic architecture, what are containers, what exactly is Docker, and what is Kubernetes, right? So I would love to now, like take up certain questions that you might be having, and I would, we feel free to, like ask any kind of questions. And again, just in case you might be having any specific doubts and you would want to connect, again, these are like my handles, so you can connect with me on Twitter at 𝐻ow_develop and on LinkedIn at Shivay Lamba. So if you have any questions related to open source, or with respect to cloud computing or Docker, you feel free to, also connect with me. So I would love to, take up any kind of questions that you might be having in the comments. So feel free to, like ask your questions. And as far as I can see, the first question is by Aditya, and he asks, is cluster computing that many are doing some subtasks, or are all independent of each other? So we spoke about the cluster computing, where we are having, or we are running the client server architecture, but we might combine two or three different types of client server architecture together. So in a cluster computation, you could actually think of it as like, running a same application, but uh, everyone is running it slightly differently. So let's say if it's like a banking operation, some of the bankers might be using it to deposit cash. Some might be using some of the application of the banking software and the banking application to run invoices generation, right? So it can be used for different application as well. And again, like in terms of the cluster that we create, right, with the help of these, they are just being used to provide a single platform, or like a single application that everyone in that locally in that network on that particular area can use at the same time, right? They are working on the same database instance as well. I hope that answers the question. And I think the next question is by Sakshi, who says, how can we choose the best cloud service providers when we have plethora of options? And again, like Sakshi, thank you for asking this question. And this is something that, is probably one of the most commonly asked questions, because a lot of these different cloud services are having very similar kind of services. And it really just depends on the kind of application that you're building. And initially, when you start off with building a large application, you might actually be hopping on between different types of cloud service providers. Some of the cloud service providers are well suited for some kind of an application. Some might be better in other ways. Some might be offering you cheaper, like they might be cheaper for you to actually utilize. And really, it just depends on the main source, or your main application that you're trying to build. And depending on what exactly you're trying to build, it would matter a lot on exactly what do you want to achieve with your application. And depending on that, you can take some time and explore the different cloud service providers. just to sort of give you an example, in case you're having a machine learning application, then having something like utilizing DigitalOcean might not be the best, because they do not have like dedicated cloud services for running or for deploying machine learning based applications. You might be much better off using Azure or AWS in terms, for example, if you have machine learning based projects, right? And for example, let's say if I am to say like the difference that which particular cloud provider provides a better translator service, text translation. So in that is GCP is definitely the best, hands down the best service that you can use. In terms of map services, like the map services provided by GCP, that is the Google Cloud Platform, are again better as compared to the map services provided by other cloud platforms. But honestly, like you'll have to try out different cloud services, and again, most of the cloud services do provide you free of cost access for a limited amount of time. For example, GCP enables you to provide $300 of Google Cloud Platform credit. AWS provides you 1 year long free tier service that they have enabled. Similarly, Azure also provides you like a free tier service for around a period of 4 to 5 months, right? So all of them will provide you some kind of free services, and honestly, you'll have to sort of really understand what exactly are you working on, because each one of them might be having different kind of experiences that you might be facing, and some of them might be better off. And a lot of times what you'll find yourself is actually using like a hybrid cloud architecture system, where you might be using some services from one cloud provider and some services from another cloud provider. So it really just depends on your application that you're trying to build. The next question is by Finber, and they ask, what companies in the current industry use Docker? So Docker as a tool, as I've already said, that it's a tool that helps you create the containerized applications. And today, almost all the different companies that you'll see in some form or the other will be utilizing Docker to basically containerize their application. Because even if in the scenario, if your application is relatively small, it's usually recommended to basically create a container of them, because since again everyone is working remotely, in case someone wants to do a quick configuration on your application, so if they were to install that from scratch, it might take up a lot of their time. So instead of doing that, what you can do is that basically just create a container, create an image of your application and share that using Docker Hub, and that will enable for a very quick sort of setup of your application by anyone with whom you share that Docker image. So most of the companies today are utilizing Docker to create the images and share those across teams, across different time zones as well. So majority of the companies are using Docker, Kubernetes, or some other form of container creation, if they're not necessarily using Docker. I hope that answers the question. Does anyone have any other questions? So feel free to sort of drop them down in the comments, because I think that we're still having like 20 odd minutes for the session. So I'll be more than happy to like take up any other questions. And also in the meantime, if you want to get started with learning about the microservices architecture, about Docker and Kubernetes, you will find a lot of different great playlists by 𝐒𝑡𝐢𝐺𝑚, by a few of the like playgrounds where you can actually get started and utilizing, and like creating your first ever Docker file will be relatively easy, because again there are only a few simple commands that you need to use. And again, just to sort of also help you guide towards how to get started with installing Docker. So on basically if you're having like a Linux based system, you simply just can install Docker with sudo apt install Docker. In terms if you're using Windows, or let's say if you're a Windows person, you can either use the Docker Hub and basically use Docker Desktop, because it provides you like a UI based front where you can like create Docker and Kubernetes based applications. So or you can use WSL, that is Windows Subsystem Linux, which essentially provides you a running state of Ubuntu and any other kind of a Linux based OS directly on your Windows. So you can use that as a ways to also create Docker files. But for Windows users, you can use the Docker desktop that helps you create either Windows based or Linux based containers. And there's a concept of hyper virtualization that also sort of enables, that basically helps you run these kind of operating systems directly on your main OS as well. And again, like if you have used some kind of like tools such as or you have run these virtual machines on your system, those require hyper virtualization. So you can use either Docker desktop in case you are on Windows, to sort of get started with at least the basic commands like the Docker run, Docker build, to create and run instances of your Docker images. I hope that helps.
Yes, sir. So I think there are no more questions, and you have answered all the questions very well, sir. So we are
Yeah,
very thankful to you that in this small duration of time, you have explained all the important technologies and regarding the cloud computing and micro
yeah,
architecture services, and you have very well explained various models that we can use, and what are the various services that we can use, like infrastructure, platform, and software as a service. So I think these all things will help the students and all the developers, they can implement these all things in their project. And you had also explained the various services and what is the importance of the cloud computing, and what are the various options among the plethora of options, how we can choose, and whether multiple, sometimes we need to use the multiple options also, like AWS and all, DigitalOcean. So how to
yeah,
select, you had very well explained. And after that, you had also explained about the monolithic architecture and the microservices, and what are the benefits and drawbacks of these all various technologies. And then you have explained the load balancers, which is very important. And you have also given the live example about relating the various companies. So I think these all
absolutely.
things had given a very clear picture of the cloud computing and microservices, sir. So I think this session was quite helpful for all the students who have joined here, and it has encouraged all the students and us and all the viewers to start working on these all new technologies on which various companies are working. So we are definitely very encouraged and motivated to get started with the cloud computing and microservices architecture. And we are very thankful for taking your precious time and joining us here. And so we will be meeting very soon with the next exciting session with all of you. And so I request all of you to stay tuned with us for the next session 4 of this Hack NITP workshop session. Okay, sir. Thank you
Thank you.
again for coming here with us.